Hello guys, so today we'll be doing question 560, subarray sum equals k. Given an array of integers, nums and an integer k, return the total number of subarrays whose sum equals to k. A subarray is a continuous non-empty sequence of elements within an array. So example 1, the nums array is 1, 1, 1, k is equal to 2, output is 2. The reason being is this subarray here is equal to 2, 1 plus 1 is 2, and this subarray is equal to 2 as well, 1 plus 1 equals 2. You can't do this one, 1 and 1, because that's not a continuous subarray. There's a space in between. So example 2, num is equal to 1, 2, 3, k is equal to 3, output is 2, again, because 1 and 2 is equal to 3, and 3 itself is equal to 3. So for this question, I'm going to show you the brute force method, which pretty much takes a count and loops through the array twice, which is therefore O(n) squared, so because it's a nested loop. And then I'll show you the optimized approach, which is using a map and a single loop, which is O(n). So let's show you the brute force first. So for the brute force approach, the first thing we do is create a variable for a counter. Then we'll have an I loop to loop for the array once, and then we have a j loop to loop for the array again. So within the I loop, we'll initiate a sum counter which is equal to the I value. So right now I is 0, so we'll set increment here I is equal to 0, and j is equal to I plus 1, so j is equal to 1 for now. So sum is equal to index of 0, which is 1, equal to 1. And on each time we change the sum, we check if it's equal to k. So is sum equal to 3? No, so count remains at 0. Then we add the j value to the sum, which is 2, so sum is now 3. Is 3 equal to 0? Yes. No, is 3 equal to k? 3, yes. So we now change count, we increment it, so now it's equal to 1. We can get 3 from 0 and 1, which I and j. Now we increment I. So we increment j again, because j is at 1, so now j is at 2. Oh. Now 1 plus 3 is 4. Is 4 equal to 0? No. So then we continue, we increment I is now 1, j is I plus 1, so it still remains as 2, but now the sum of I itself is 2. Is 2 equal to 3? No, can't remain the same, we go down. Now 2 plus j, which is 3, is equal to 5. Is 5 equal to 3? No. So we continue and we increment I is now at index position 2 as well. We don't have j anymore because I plus 1 does not exist. So we check. In position of 2 is 3. Is 3 equal to 3? Yes. So we increment the counter. Counter is now 2. And now the loop breaks and we return the counter, which is 2. And let me show you how we do this in code. So we initiate a counter variable. We set it to 0. Then create a for loop. So for let I is equal to 0, numbers I smaller than numbers.length, we increment it. Now we create a sum variable which is equal to nums I. If nums I is equal to k, so if sum is equal to k, then we increment the count. Then we create the second for loop, the nested for loop, which is for let j is equal to I plus 1, in which j is smaller than nums.length, I plus plus. Sorry, j plus plus. Then we increment the count, the sum, by adding numbers j. And again we check if sum is equal to k, then we increment count. Then at the bottom, return the count. Let's submit. This passes. Let's submit. I can see it passes, but it is very, very slow, of 1,500 milliseconds. And there is a very optimized solution, which I'll show you now, which is using a map. So let's delete this. Let me show you in the whiteboard. Okay, so for the optimized solution, we have to, again, we create a variable which counts the current number that of subarrays that equal to k, so we set it to 0. Then we again set a counter that counts the current sum, so sum, we increment to 0. But for this one, instead of doing double for loop, we use a map to store the current sum each iteration of the for loop. So create a map, and as before the map starts, the current sum is 0, we have to add that as well. So we set 0 as the key and 1 as the value, as we come across 0 one time. Now we have to loop through the for loop again, so we have an I value of 0. And so now I is equal to 1. We increment the sum by I. So we set it to 1. Then we check if the sum minus k exists in the map. So does 1 minus 3 exist? No, because that's minus 2 and there's no minus 2 in the map. So we set the sum and the frequency of it in the map. So now in the map we have 1 and 1. We come across a sum of 1 time. Now we increment I is now equal to 1. So we are at 2. So we increment the sum by 2, sum is now 3. Now we again check the sum and delete it from k. So that equals to 0. Do we have 0 in the map? Yes, we do, here. So we increment the count by that value, which is 1. So count is now equal to 1. Now, completed that, we again iterate through the for loop. So I is now 2, which means we are on 3. So sum is now equal to 3. Oh no, we also have to add, we add the sum, which is 3, before that. Even if we find the value in the map, we add the sum. So 3 is equal to 1. Key of 3 has value of 1. So we come across the sum 3 one time. Now we're on I is equal to 2, which is 3. Now sum 3 plus 3 is 6. 6. So we check again. Sum minus k, 6 minus 3. Do we have 3 in the map? Yes, we do. And we've come across it one time. So we increment the count by that value, which is 1. And we proceed. Now the for loop is finished because I is 3, which is bigger than the length. So we return the count. Sorry, not I is 1, I is 2. We come across it 2 times. We incremented it twice. So we return the count, which is 2. And that is the result. This is faster because it's time complexity of O(n). We only loop through the array once. We also store a map which is higher space complexity, which is of O(n). So the first thing we do again is increment the count. Then we set the count. Then we set the sum, which is equal to 0. Then we set a map, which is a new map. And then we set values in the map, as mentioned. Set a key of 0, the value of 1. Then we loop through the array. So for let I is equal to 0, die smaller than nums.length I plus plus. So we increment the count by a current I value. Then we check if the map has sum minus k, then we know we can get to the k value. So if it does, we set the count, we increment it by map.get sum minus k. After, whether it does or doesn't, we still have to set it in the map that we come across that sum. So we set either. So we set the sum as either. If we have got to the sum already before, we get it. So sum minus k. Or if we haven't, we set it as 1. So we either get it and increment it, or we set it as 1. Then we return the count. Let's run. Wait. It's not map.get sum. Not map.get sum minus k. Let's submit. Look at the difference between the previous solution and the current solution. 1,100 milliseconds versus 18 milliseconds. As you can see, it's much improved. The time complexity is now of O(n), so you only loop through the array a single time compared to the previous nested loop. But however, the space complexity is a bit more, which is also O(n), as we're storing again the whole array, where the previous one we wasn't storing any array. Thanks for watching.